I'd like to invite Darren Edery to share his thoughts on cloud environments and provide his closing thoughts on our morning sessions. For those who don't know Darren, Darren is the Chief Executive Officer of Adastra North America. He steers the strategic direction of Adastra Corporation to deliver best-in-class solutions to global enterprises. During his 12-year tenure as CEO, he has led the charge in positioning Adastra as a holistic solution provider of data and AI-driven digital transformation, expanding the breadth and depth of Adastra's expertise related to data and analytics, digital governance, and cloud services. Darren is a thought leader in technological innovation and is a passionate advocate about women in STEM and finding and developing talent in the data space. Over to you, Darren.
Before I get started, just want to thank everyone for joining today. Great attendance from not only here in Canada but globally. So a hello to everyone who's joining us from far away. Thanks to all our presenters from this morning. Fantastic job, Christian, Rob, Krasen, Zishan, Mia, Rahim, Marcos. Marcos, I hope you took that little dig about being a nerd in the spirit it was intended from a fellow nerd. And I especially wanted to thank our guest participants, Mark and Karen and Ariana. Thank you. And the panel, I thought was really, you're really fantastic. Mia, you had the one of your comments towards the end that really resonated with me is this idea of, I don't think you use this term, but I'm going to call it self-monetizing, right? As people become a little bit weary or leery about what information they share. Mark also did a really good job of articulating that concern. So this idea of self-monetizing, it's actually something that Adastra's founder, Jan Razik, had been talking to me about as early as the late 90s, this idea of a personalized data warehouse, where we all have our data existing in some standardized model that we own and can choose to share and publish and negotiate price with. So everything comes full circle, and then that's maybe a great business opportunity for someone out there to monetize the idea of self-monetization. Okay, so what am I talking about today? Data and analytics on the cloud. I think the presentations this morning were so good, very conceptual. I actually think my presentation is a little more on the pragmatic side. So hopefully you'll indulge me being a little bit focused on pragmatic. So data and analytics on cloud. So apparently cloud is a thing, right? And as Christian introduced me and talked about how many years I've been with Adastra, it actually brought back a memory. So I'm going to go a little bit off script here and talk about cloud and its origins. So back in there might be some of you in today's session that would remember this, but back in 2010, Adastra hosted a conference, and the keynote speaker was a gentleman named Roman Stanek, who was actually the person who created Java Beans and sold it to Sun Microsystems, and was incredibly rich. And after that, he started a company which is still going strong today called Good Data. And they were one of the first cloud-based analytics company and sort of the first BI on cloud company. And this was, again, in 2010, where cloud was really in its infancy, especially in Canada and especially in data and analytics field. And at that keynote that Roman gave at the time, he talked about how if your organization was running a data center with less than 10,000 servers, you were essentially a hobbyist. You were no different than some guy, let's call him Marcos da Silva, with 4 or 5 servers in their garage, right? So at that scale, and if you're the largest organization in Canada and you think you know what you're doing from a data center perspective, you're actually mistaken, and only the small handful of the largest companies in the world that specialize in running data centers actually know what they're doing. So if you're thinking that, your risk of security breach is, which is something that we also talked about on the panel, is somehow less than being on cloud, you're deluding yourself. And he talked about things like over time, the price of computing will converge to the price of electricity, and the only decision around where a cloud data center should be is where the electricity is the cheapest and perhaps the most environmental. I remember, I thought it was such an interesting keynote at the time, again, 2010, the same year that Azure launched, I think, 2 years after AWS launched, and I think around 2 or 3 years after GCP launched. I might have AWS and GCP flipped in my mind. So, the reaction from the crowd was like, this guy is a crackpot. But fast forward to today, while those claims might still be a little bit controversial, I don't think no one would say he's crazy as that they were at the time. So cloud is a real thing, and I think that we see that the adoption to cloud, even in that data and analytics, just continues to accelerate. So that being said, why are we supposed to love cloud? So speed to market, I think, is one of the real big advantages, and we see that in things like the provisioning of analytical sandboxes that can be done in almost instantaneously. Whereas we all lived through the time in the on-prem world that, by the time we get a server shipped and installed on the floor and connected and tested, we're talking about weeks or months or quarters. And again, reliability, security, disaster recovery, those are things that are readily available and well used and well understood in the cloud space. Portability, mobility. I think your mileage will vary depending on the type of tools or services that you use. Some might be stickier to the particular cloud platform, but for sure those advantages are well understood and well utilized. Where I think where the challenge is and where we're going to focus today is on perhaps the two biggest potential advantages of cloud for data and analytics. Cost, more importantly, cost structure. I think that most organizations are recognizing that there is not necessarily an immediate cost savings on cloud. Perhaps over time that will change, but it's the cost structure and how it relates and interoperates with flexibility and elasticity, which is really what's advantageous, but at the same time potentially really dangerous, as we'll see. So just to clarify and differentiate what I'm talking about. So looking at the cost of cloud in the application space, not trivial, but at the same time, fairly straightforward, right? If we think about running our order entry system, our ERP system, our finance system on cloud, whether it's a greenfield implementation or whether we're doing moving from on-prem to cloud, the workload, the demand on the system, the growth projection and forecasts should be fairly deterministic and linear, and therefore our ability to understand the cost and model the cost over time should be quite straightforward. That being said, we see our customer experience sometimes is, we've seen as much as a 5x miscalculation or cost overrun on application. But if you think about data and analytics, this is a much harder problem because the workloads are much more difficult to predict, much more highly variable, and so it's much harder to model and estimate and control costs on cloud, in the data and analytics realm. One point I just want to clarify that, if this slide's a little bit misleading, this isn't about any given platform. The slide might look a little bit like it's geared that way. This is really about the workload type, application versus data and analytics. Okay, so let's talk a little bit about the good old days, right? Anyone, of my vintage or a little bit younger or a little bit older, remembers the 80s and the 90s so fondly, right? We all drove our DeLoreans to work, where we mounted tapes in data centers. And, this is the world of on-prem. So, the best way to understand that is, you would buy a fixed capacity at a fixed cost. And the analogy to understand this is really like if I have my bundled cable TV service or my unlimited phone plan, right? And you've paid for it all, so the more you use, the more value, or at least perceived value, right? So there is the issue of heat versus light. So if I'm watching the season finale of Queen's Gambit with my daughter, maybe that's good value from the plan. If I'm up at 4 a.m. watching reruns of Doomsday Preppers, maybe that's not the best use of my time. But what it means is that the higher the utilization, we feel we're maximizing the value of the investment. And what it all sort of boils down to is that model incentivize maximum use. If we think about life today, if we could go anywhere, of course we'd all be going there in our flying cars, and interacting with cloud data centers, and the new paradigm of cloud data and analytics. It's really a variable capacity and cost, and analogous to a pay-as-you-go model. So in this case, every use has incremental costs. So watch what you want. And only what you want, and only where you perceive value. And if you're nostalgic and you like some of the features of the old model, then obviously hedging is something we can do to have the new paradigm with some of the features of the old paradigm. But in the cloud world, the incentive is to minimize use, because the less we use, the less cost we incur. So let's compare these things a little bit in a little bit more detail, right? So in the on-prem world, workloads or queries, up to the maximum capacity of our server are essentially free, because we've already paid for the capacity, and therefore any workload or query within that capacity, regardless of business value, it is typically run. On cloud, every single workload or query has an incremental cost. So the decision to run any what I'm calling an optional workload, so this would exclude things we have to run for regulatory or safety reasons, but any optional workload ideally is linked to business value and positive ROI. So am I getting more business benefit from running this query than cost that I'm incurring? And obviously this is difficult to model. I think that this, organizations and the industry is a significant way away from that capability, but I think we should all be striving to being able to value workloads and queries and be able to do that math. And I think that if you take this to the extreme, we should be running every single workload and query that provides a positive value and ROI, sort of up to the practical limitation of what our organization has the capacity to execute, and take action from the insight. Another interesting difference is that in the on-prem world, that there's actually little incentive to write efficient code and to do performance optimization. Generally the only thing that drives these kinds of activities are service level requirements. So whether that's you have a given window and a job needs to run within, or the response time that a user witnesses for a query, and there's almost this sort of perverse incentive that because we associate the maximizing capacity to maximizing value, that we can feel good about ourselves if our server is maxed out or near maxed out, because we feel we've maximized the investment, but that's not really letting us know how efficient or optimized our code or processes really are. In the cloud world, this is extremely different, right? Any effort associated to making code more efficient or optimizing a process in excess of the cost to perform the optimization provides a positive ROI. And we see that cost variability being 1000x or more, including additional orders of magnitude more between inefficient queries and processes and highly optimized queries and processes. So while not all cost necessarily scales linearly, but you can imagine, and we'll see later on in an example, the difference between optimized and non-optimized queries, and the cost implications. So the need and ability to do optimization and write efficient code becomes dramatically more important. Similarly, in the on-prem world, we would look at development costs decoupled from to a large degree, to the compute resources that were required, right? So as long as what we develop can run on the capacity that we have, no one thinks about the compute costs as a consideration along with development cost. But in the cloud world, we don't have that luxury, or we're not. We don't have that luxury. So an example is, if an organization is considering two alternatives to develop a workload, it might be an internal team versus a vendor team. It might be a vendor A versus vendor B. So if team A is saying, well, we can develop this workload for $500,000 of development costs, but it's going to consume $200,000 of compute costs a year. And option B can do the same development for $1 million, so twice the development costs, but run at $25,000 of compute costs per year. Which option is cheaper, right? So it becomes more complicated to assess the relative cost of a development efforts. And then finally, in the on-prem world, my observation, having worked with many large enterprise customers and SMB customers as well, is that everyone likes to build new stuff. Old crap rarely gets decommissioned, and in the on-prem world, generally the cost of not decommissioning is low, because what you're not decommissioning generally has been fully depreciated from the accounting side. Maybe you're paying some maintenance cost on licenses, but maybe you've stopped paying license costs, but you've still got this stuff you haven't truly decommissioned. Whereas in the cloud world, as early days we already see that orphaned, unused, abandoned, whether it's virtual machines or workloads, persist. You're not getting any value from them, but the bill keeps running up. So the analogy I use here is, if you've bought a monthly subscription to a fitness app and you're not using it, but at the same time you never canceled it. So some stark differences. And I think the conclusion, and really this is sort of the major thesis of my presentation. I encourage you to stick with me to the end, but this is really the most important point, is that the complexity of governing cost in the data and analytics on cloud world, it's an order of magnitude more complex than in the on-prem world. And so we need specific muscles, capability, organization, and process to manage cloud cost that frankly we didn't need before. Okay, so what role do cloud platforms play in solving this issue? Look, on the one hand, their business model is very much incented and driven to maximize consumption and spend, right? So I think we all understand that your cloud platform provider of choice, or more than one, or all, they want you spending as much money as possible. That being said, working closely with these organizations, none of these guys want to see your organization wasting money, spending more than is commensurate with the value obtained. And as we'll see, they provide tools to help us manage these costs. So on the one hand, yes, they all are trying to drive your consumption and spend, but they want to see value. And I think that it's such a competitive market. And we talked about one of the features of one of the reasons we're supposed to like cloud is portability and mobility. So the risk of attrition, or the ability to go to a competitor competitive cloud platform acts as a really strong incentive to make sure that while these organizations want to see your costs go up over time, it needs to be in a way that's commensurate with value. So don't think of the cloud platforms as bad guys wanting to give you a huge bill for things where you're not receiving value. So yeah, this is an interesting slide. So I'm going to go a little bit on a tangent here. So probably many of you know, but maybe for the few that don't know, and it's maybe good to emphasize even for those that do. So, Adastra works with all three of the cloud platforms that we saw in the previous slide, and we have practices and capabilities on all three clouds, and we have teams that are focused on each, and we have folks that work on cloud more holistically. But as I was doing some research for this presentation, I asked our three cloud teams, for their perspective on this subject, and our colleagues on the Azure team, sent me this slide, and I think their intent was to show, look, Synapse is the most cost effective. So the way you solve the cloud cost challenge is to run Synapse, right? And so I think this is a good point for me to say I have no opinion on this. I'd much rather take on something less controversial, like which is the most effective COVID vaccine. So I'm not going to touch what's the best cloud. I'll give this analogy. I coincidentally have 3 children. I love them all, right? So that's kind of like a multi-cloud answer. And who is the best kid? It really depends on the day and who's listening. But the real reason I decided to include this slide, even though I'm not here to make the point that maybe our Azure guys were trying to make, is that actually this is a little bit of a distraction, because this talks about relative cost for some given workload. But as an organization, your focus needs to be on what are my absolute costs going to be. And I think that focusing on relative costs, well, may be important, especially as you understand the nature of your workload. At the end of the day, what you're going to get a bill not based on relative cost, but based on absolute cost. Okay, so I talked about this idea of a bundled plan or a pay-as-you-go plan. So I'm going to continue that analogy a little bit. So as we worry about how to deal with our cloud bill, I think what we don't want is, and everyone remembers, in the early days of cell phone plans, and maybe it persists on a limited degree, but certainly before unlimited plans were widely available. You'd get the surprise phone bill. Oh my goodness, I didn't realize that this particular call was going to be so expensive, and you're calling your provider to try to negotiate. So that's exactly the situation we want to avoid. And the way to do it ultimately is to have an understanding of what my bill is going to be, understand what drives my costs, so that you're not getting a surprise on the bill. And the process is pretty straightforward, right? So it's budgeting and forecasting. How much do I anticipate spending? Tracking those costs, doing them at a granular level. Monitoring your spend as you go, so that at the first sign of something unexpected, you're able to react. And trying to be as proactive as possible through things like alerting. All 3 cloud platforms provide out of the box some really good and improving tools to help us do this. So this is actually a real world example of some internal reporting that one of the Adastra teams for some services and workloads that they're running on Azure. So it's pretty nice, right? We can see what we're spending, how it compares month over month, what the cost breakdown is, and how it's forecasted out to the future. So pretty good. And beyond just here's the information, and again, all the platforms provide these capabilities. Some recommendations of, hey, here's how we think you can change the way you're doing things to reduce your cost, right? And so that's an example on Azure. Same thing here for AWS. And again, I'm not taking any religious stand on better, different, worse. Frankly, I don't know, and your mileage will vary depending on your needs. But what I would say is about all of the recommendations is that if you think about it, they're limited in the sense that they're fairly generic. They don't necessarily understand the business context, and they're limited in how holistically they can be advising. So the capability is good and it's improving, but to think, well, I don't need to worry about cost and cost management because I'm just going to take all the recommendations that my platform is auto generating. It's not good enough. So let's go through this use case quickly. So we talk about opportunity A. So this is what kind of a reactive situation, but it demonstrates. I talked about the huge potential variability of cost for non-optimized versus optimized workloads. So we have a real life example where we had a customer running a query. It took 10 minutes to run and a cost of $9,000. So probably not the end of the world. $9,000. It's not the most. It's not the most amount of money, but for the value that it was generating, it didn't make sense. And every time we run that query, we're going to incur that same cost, right? With really minimal but highly specialized and highly expert optimization, we're able to reduce the execution time from 10 minutes to I think sub-second or a small handful of seconds, and the cost to under $5, something like $3. So it's a huge win. It's a great success story, but we don't want to be in this firefighting mode where every time a query pops up that's more expensive than we anticipated, or we look at all of our expensive queries and then reactively go and optimize them, right? That's better than doing nothing, but it's not where we want to get to. So what we're calling opportunity B and is something where we're going from reactive to proactive. The idea being, before we run a query, let's have some estimate of what it's going to cost, understand if the cost is nominal and modest, maybe we go ahead. If the cost is significant, then we think about, is it worthwhile relative to value, or do we need to do some optimization before we run it? So this is not a capability that is something that is there available today on any of the platforms at this level of ability. But with some tools that we've developed, we can help organizations pre-run your analytics to see what your cost estimates will be, and dashboards to track how the estimates track to actual. So getting from reactive to proactive. Other things that we can do, things like making, this is kind of like putting in the phone bill analogy, this is like making sure we don't make those calls that show up on our bill that generate those surprises. So things like governing how big a query can be in terms of the number of bytes. So if we try to run a query that's too big, it doesn't run. We can put things like runtime restrictions, so a query only has so much time to run and complete, and if it doesn't, we stop it, right? So these are kind of crude tools, but at the same time, useful and necessary. An important thing that we need to do is, as we try to understand our cost, and this is actually a significant enhancement or differentiator relative to the on-prem world. So again, I'm going to go again a little bit on a tangent. I remember working for a large bank where there was some shared infrastructure for analytics across a number of different lines of business. And every year, and often more than once a year, there were fights because line of business A is not paying their fair share, and they're using the box more than we are, and the way we're distributing costs isn't fair and doesn't make sense. And was a constant fight, and no one was ever really satisfied. We have the opportunity now to link services to cost centers. So our ability now to provide visibility for who is running what, and therefore who owns the cost, can be very, very granular and very good. Now, the problem doesn't go away completely. There certainly will potentially be some shared components where we still have the cost sharing challenge. But even then, we can look at the other use as a proxy for fairly distributing cost, and the ability to structure work so that services are aligned to specific cost centers is really good. So this is an important practice that you need to adopt. So to understand, what a particular cost center or line of business is generating in terms of cost. And so this slide talks about the idea of cost incidence, right? So this is suggestive of that need for governance, not just in terms of tools and capabilities, but also in terms of organization and process, right? So in this case, we have some workload that it runs fine, but a new version is implemented, and that triggers some auto scaling, which is driving much bigger consumption than the process was previously. This generates an alert, so that's good. So we know, hey, now there's a problem, but how do we deal with it? So this is where we're introducing this idea of a cloud cost governance office. That name, maybe you like it, maybe you don't, and maybe it's a work in progress. But the idea being that you need an organization within your organization, and for small enterprises, maybe that's one individual, but certainly in large enterprises, that needs to be a team with skill sets across your multi-cloud platform, both technical and process skills, to be able to assess this alert. Maybe that auto scaling and the increased cost makes sense because of the change the change was driven by business need and a business problem at a larger scale. And then how do you resolve that both at a technical and a business level, and how do you manage that challenge? One other thing I want to talk about is, I mentioned hedging early on. So all the platforms provide some capability to trade off elasticity in exchange for better pricing, right? So if I commit to some commitment of spend and the capacity that's associated with that allows me to lower my price, and all of the platforms have this in different flavor. But again, it's complex decisions about if and when and how much reservation or commitment do I make, because while it provides lower cost if I use it, I've committed to that spend. So again, not a trivial problem, and you need a dedicated capability in your organization to make those decisions. So the conclusion is the need for your organization to whether you have this formal organizational structure or not, the capability to look at all of these things holistically together. And we're recommending, so Adastra's perspective on this is that this is hard, this is complex, this is multi-discipline, multi-domain, and it's new. So we've helped a few organizations, and we hope to help quite a few more establish this process, create a cloud governance office. We have a very concise and high value offering where we'll spend 1 week helping you launch your cloud governance office. So that's something that I encourage our customers to take advantage of or to ask questions about. So that's my presentation, and thank you all very much.